Let's begin section 11.3. And in 11.3, we're talking about rates of change. And we're getting into that understanding. Remember, we started with section 11.1, which had to do with limits. And we learned that there could be a removable point and still have a limit. And we learned that if they never meet or plan to meet, in other words, we have infinities, well, then we don't have a limit. So we look at limits to figure out what is the function doing at any given point. Then we talked about continuity in section 11.2. In continuity, we talked about the function has to be connected between two parameters or around the number that we're actually trying to find a limit for. And now we're going rate of change. Okay, rate of change. And this is our intro to calculus with reference to limits. All right. So we're going to start easy first to understand the connection of slope as a rate of change. In other words, distance is equal to rate times time. Well, rate is average rate of change. And average means an average between values, the start point and the end point. So we're going to start with the average rate of change. And we're talking this function. So in a closed interval, point A on x to B, then we take f of B minus f of A and divide by the x values, B minus A, the destination minus the origin. And that'll give us the average, how much distance we've changed. Well, we notice that is closely related to slope. Y's of 2 minus y's of 1 over x of 2 minus x of 1, which is kind of the same thing. But in this case, we're talking about change within within 2 points on any graph, not a line, but any graph. And then we're going to see that this creates a secant line because it's from one point to another. And so the rate of change is like the adage, as the crow flies. So let's find the rate of change for this example. All right, so here we have, find the average rate of change, which was the one above, for the given function of parabola x squared plus 12x between x is 0 and x is 7. All right. So write the expression. What expression can be used to find the average rate of change of the function f of x and from 0 to 7. Notice that we have a closed interval. All right. So let's look at that graph. All right. So we're going to get our calculator out, and we're going to enter x squared, second row, second key, and then x squared, the fifth key down, plus 12x. And we're going to go zoom 6 for a standard window. And I only see a part of the parabola because it is so big. And we're talking 0 to 7. So I'm going to change my window a little bit to -3. And we're going to do, let's do 25. And we're going to do increments of 5. And then we're going to do negative 3. And we're going to do a positive 0.25. Let's do that and see what the graph looks like. If we can see the parabola easier. Well, we can't. We still don't see the bottom, but we know it's going up. It's going up to infinity on this end because it starts at 0, 0. So let's see what we have here, because it looks like a straight line, but it is a parabola. So we want to state that it is f of 7 minus f of 0 over 7 minus 0. So you can see that we have the value of x there from the destination to the value of x at the origin. So that would be how the function states. So we want to find this average rate of change. So let's do the math on this and find out what it is. So we're going to do f of 7, which is going to be 7 squared plus 12 times 7. And we're going to do our calculator, of course, because this is, kind of heavy. 7 squared plus 12 times 7. And we're going to get 133. And now we're going to do f of 0. Well, f of 0 is easy because we have 0 squared plus 12 times 0. So we get 0. All right. So now we're going to construct the problem. So I'm going to have 133 minus 0 over 7 minus 0 for the average rate of change. 133 divided by 7. And we're going to do a calculator for that. 19. All right. So the rate of change, the average rate of change, for the interval 0 to 7 is 19. It's going very fast, isn't it? Because it is greater than 0. So that tells you, and the direction is positive. So now we want to look at this next one. And in this case, we're looking at a radical. And in this radical, we're saying find the average rate of change of the function over the given interval. Our interval is 3, and it stops at 11. All right. So we want to first find f of 11 and f of 3 in the function. So I'm going to have 2 times 11 plus 3. Excuse me, my eyeball is itching. 22 plus 3, 25. So f of 11 is 5. The square root of 25 is 5. Now we're going to do f of 3. So I'm going to have the square root of 2 times the 3 plus 3. That's going to give me 6 plus 3, 9. And of course that's going to give me 3. So I'm going to use my average rate of change, which is another word for slope, for a closed interval is, all right, now I'm going to put in my values, the 5 minus the 3 divided by 11 minus the 3. And I'm going to have 2 over 8, 1/4. All right, so my average rate of change is 1/4. All right, I'm going to stop right there. And I'll continue on with the instantaneous rate of change and discuss that then. Okay,